when we are subtracting lowest value from highest value. That is what, there will be two cases. We have to add this end around carry back to the LSB. That is what, least significant bit. That is what, subtracting a smaller number from the larger number. Hello everybody, welcome back to the 7th session on 3rd chapter, that is data representation. I am Rohini TS from the Department of Computer Science, Vidhyaashram Pre-University College, Mysuru. So in the previous session of this chapter, that is what, data representation, we have discussed regarding the binary subtraction. What are the rules are we supposed to follow when we are working with a binary subtraction? Okay, so there you have to concentrate the rule when we are supposed to take the borrow from the leftmost bit. That is what you have to concentrate there in the binary subtraction. And this binary subtraction is also important for 1 and 2 mark question. After that, I have discussed regarding the representation of a signed integer. So what are the methods that we are going to use in order to represent the signed integer? So as we all know that digital computers will going to have both positive numbers and negative numbers. Then what are the methods are we supposed to follow when we are working with a negative integer? There are 3 categories. We are going to use sign and magnitude method, 1's complement and 2's complement. So these are the methods that we are going to use in order to represent the signed integer. So in the sign and magnitude method, first bit will going to be represented for the sign. Okay, so if we are having minus sign, instead of that we have to take a value called 1. So if it is plus, then we have to take 0. So that is regarding what? Sign and magnitude method. So in the 1's complement, whatever the value, what is the binary value they have given, we have to convert all zeros into ones and all ones into zeros. Then that will going to give us 1's complement. Then regarding 2's complement, it is nothing but what? 1's complement plus 1. So that will going to give us 2's complement. Whatever the binary number is there, we have to take a 1's complement of that. Then we have to add 1 to the LSB, that is least significant bit. Then that will going to give us 2's complement. So in our today's session, we are going to learn with a subtraction of a binary number, that is by making use of 1's complement, and subtraction of a binary number by using 2's complement. So this will be the content of my today's session. So now we'll see about the subtraction of a binary number, that too by making use of the complement, so that it will going to include both 1's complement and 2's complement. So now we know what is 1's complement and how we are going to find the 2's complement. Then how we are going to perform this binary subtraction, that too by making use of 1's and 2's complement. So as we all know that computer understands only zeros and ones. So if I want to perform any of the operation, then it has to be in the terms of zeros and ones. So there, in order to perform the arithmetic operations, we are going to use the circuits. So why this subtraction is so inexpensive or less expensive? So whatever the circuits that we are going to use for the addition or a binary addition purpose, then same circuit will going to be used for the binary subtraction with slight changes. So that is what the reason this binary subtraction will be less expensive when we are working with a computer, that too with the help of circuits. So now we are going to see about the subtraction of a binary number by making use of a 1's and 2's complement. So first I wanted to tell you something, that is what you have to remember what you mean by minuend and what is subtrahend. So as I discussed, minuend is nothing but what? That is upper value, right? So this is highest value or a upper value, that is upper number we can say. Okay, then subtrahend is a number which is at the lower line. That is what? It will going to be called as lower value or lower digit. Okay, so minuend is the upper digit or upper value and subtrahend is the lower value or a lower digit. So there will be 2 cases. So when we are subtracting highest value from the lowest value, okay, that will be one case. So another case will be like when we are subtracting lowest value from highest value. That is what? There will be 2 cases. So when minuend is greater than subtrahend, okay, so when minuend is greater than subtrahend, that will be the one case. when subtrahend is greater than minuend, then that will be the another case. So we are going to have these two cases, and by making use of these two cases, we are going to subtract the binary values with the help of even 1's complement and with the help of even 2's complement. Okay, so two cases you have to remember. For example, subtract 5 from 7. Okay, next subtract 7 from 5. So what is the first condition here? 5 from 7. As I discussed, whatever the value is there after from, then that will be related to minuend, right? So here subtrahend is lesser than minuend. That is what I can say. Minuend is greater than subtrahend. But here subtrahend is greater than minuend. That will be another case. Okay. So there will be two cases when the subtrahend is greater than minuend, when the subtrahend is lesser than minuend. So based on that two condition, you have to remember what are the steps are we supposed to follow and how we are going to do the subtraction. Okay. So now we'll see the case 1. So now we are doing the binary subtraction by making use of 1's complement. Okay. So what is the case 1 here? That is what? Subtracting a smaller number from a larger number. So here, which case holds good? Minuend is greater than the subtrahend. Minuend is greater than subtrahend. So minuend is nothing but the value that I am going to write in the upper value. So subtrahend is this one. So here it will be minuend, this will be subtrahend. Okay. So what is the criteria now? Minuend is greater than the subtrahend. So that whatever the value is there in the upper value or a upper digit, that will be greater than this lower digit. For example, subtract 7, 5. That means what? Subtract 5 from 7. 5 is subtrahend and 7 is minuend. Which is greater here? Either 7 or 5. That is what? 7. So that minuend is greater than the subtrahend. Okay, so we'll see the first step. First, we have to find the 1's complement of the subtrahend. So whatever the value will be there in the lower digit. Okay, so we have to find the 1's complement of that number. So we have to take the 1's complement of subtrahend. That will be the step 1. So in step 2, add this to the minuend. So don't get confused. We are performing the binary subtraction. Once I complement it and once I add it, then that will going to gives me the difference. Okay. So don't get confused at all here. First we have to take the 1's complement of a subtrahend. Then we have to add it to the minuend. Whatever the subtrahend value is there, we have to take 1's complement. After getting the 1's complement, that needs to be added with minuend. That will be step 2. So in step 3, carry is generated. So why I am saying carry instead of borrow? Because we are performing addition. If we are performing addition, I am going to get carry, not borrow. Okay. So that carry will going to be generated. Then we have to take that carry as a end around carry. When I add this 1's complemented subtrahend with the minuend, I am going to get the carry. And we are going to call that carry as what? End around carry. Okay, that is step 3. So in step 4, we have to add this end around carry back to the LSB. That is what? Least significant bit. So which is at the rightmost bit, that will be considered as least significant bit. So we have to add that carry, whether it can be 0 or 1, but we have to add that carry to the LSB. And we are going to get the final difference. So if it is a difference, that is what we had done with subtraction. Okay. Take the 1's complement of subtrahend, add it with the minuend, then we are going to get a carry. That carry has to be added with LSB. We'll see the problem, then you can understand. Subtract 15 from 23 using 1's complement. So what we are doing here, we are subtracting 15 from 23. So that which is minuend and which is subtrahend, what we have after from, so that is what? 23. So that I can call this as a minuend and this will be subtrahend. So which number has more weightage here, either 23 or 15? 23. So 23 is the minuend, that is upper value or upper digit, and 15 is the subtrahend, that is what? Lower digit. Okay, so you have to write this in a step-by-step manner, and this type of question is very important for 5-mark question. Okay, so subtract number from number using either 1's complement or 2's complement. Okay, at the time you have to find out which type of case are we dealing, whether minuend is greater than subtrahend or minuend is less than subtrahend. So those two cases you have to be very conscious. So now we'll see the problem. That is what I'm subtracting 15 from 23. So that first value is what? Minuend. So here we have a decimal value. I have to find the equivalent binary value. So we cannot deal with only decimal. Why? Because we are performing binary subtraction. So we have to write the binary value. So minuend is 23. How we are going to get 23? By making use of 8421 format. You just remember that 8421, here it is 16. By making use of 8421, that is not enough for me to get the value of 23. So that I have to take one more value, that will become 16. By adding which and which number I can get 23. We'll see now. I'm going to take 16. And I am going to take 4, then 20, 22, and 22 plus 1 will be 23. Okay, I don't want to take 8, so that in the place of 8, I am going to give it as 0. Okay, so this is what? Minuend. Subtrahend value is what? 15. We are performing subtraction, so that I am taking minus. Okay, so 15 in the sense what? By adding 8, 4, 2, 1, we are going to get 15. Okay, this is minuend, this is subtrahend. So which number has to take the 1's complement? Are we supposed to take 1's complement of minuend or a subtrahend? We have to take the first step. That is what we have to see here. We have to find the 1's complement of a subtrahend. So now we got to know that this is a subtrahend. Now I have to find a 1's complement of this subtrahend. Okay, that is the first step. 1's complement of a subtrahend is, so what I am going to get when I complement it? All 1's become zeros, all zeros become 1. So that it will be going to be 1 and the remaining will be 0. Then in step 2, and here we have to add this 1's complemented subtrahend with minuend, right? So this is 1's complement value. Okay, this is step 1. So in step 2, I am going to write the minuend value. That is what? 1, 0, 1, 1, 1. Okay, and this 1's complemented subtrahend is 1, 0, 0, 0, 0. So now I have to add. Okay, now 1 plus 0, 1, 1 plus 0 is 1, 1 plus 0 is 1, 0 plus 0 is 0, 1 plus 1 is 0, carry 1, right? So as I discussed, we are going to get a carry. So if I get a carry, what I should do? So we'll see. Carry is generated. This carry is called end around carry. I'm going to call this carry as a end around carry. Then where should I put this 1 or any of the carry? So here I got 1 as a carry. Then what we supposed to do? So here add the end around carry back to the LSB. I have to add it to the LSB. So which is the LSB here? That is what? The rightmost digit. So I can say this as LSB. Okay, I have to add this 1 to in the place of this LSB. So now it become 1. So I have to do the addition again. 1 plus 1, 0, carry 1, 1 plus 1, 0, carry 1, 1 plus 1, 0, carry 1, 1 plus 0 will be 1 and 0. If it is 0 at the leftmost digit, then we can ignore. Okay, so now what I got? 1, 0, 0, 0. So what it mean? Which is the number that is equivalent to this one? That is what? 8. Okay, so from 23 minus 15, we are going to get 8 as a result. That is what we got it here. Okay, so this is what the mechanism that we are supposed to follow in order to subtract given number using 1's complement. This is related to case 1. So when subtrahend is lower or lesser than the minuend, or else we can say when the minuend is greater than the subtrahend. So here At the end around carry, I have added it to the LSB. Here this will be the LSB. I am going to add this carry, end around carry to here. Then we are going to get 1000, that is the base 2. So that the difference is 1000. Okay. This is regarding case 1. So now we'll see the case 2. So what is the case 1? What was the case 1? There minuend is greater than the subtrahend. But what if we have a lower digit is greater than as the upper digit? Then that will be the case 2. Okay. So case 2, subtracting a large number from a smaller number. That is what minuend is lesser than subtrahend. And understand one thing, whatever could be the number, whether it is a greater number or a lower number, don't ever think that the number which is greater is always must be minuend, the number which is lesser always must be subtrahend. Okay, that is not the case here. So we have two cases as I said. So here we are dealing with when the minuend is lesser than the subtrahend. Then what is the first step? We have to find the ones complement of the subtrahend. Again here also I have to find the ones complement of a subtrahend. So in the step 2 we are going to add the value, that is what ones complemented subtrahend will be added with minuend. Okay. So in step 3 there will be no carry. So when there will be no carry, when minuend is lesser than the subtrahend, then we won't get the carry. So that if there is no carry, then we have to recomplement the answer in order to get the difference. So if there is a carry, we are going to add it with LSB, then addition will going to happen. But here we are not going to get carry, so that we have to recomplement. It must be ones complement. Okay. So we'll see the problem. What is this? We have to subtract 52 from 25. So 52 from 25. From in the sense, I have to take this as a minuend and this 52 as subtrahend. Okay. So we have to find, and what we are going to get, we'll see. So in the minuend, we are going to get 25. In subtrahend, we have 52. So now we have to perform the binary subtraction using ones complement. So what is the equivalent value of 25? That is what, by making use of this 8-4-2-1 format, we have to find. So 16, 16 plus 8, 24, 24 plus 1, 25. The remaining value will be 0. Okay. So, but this number is not enough for me to find the value of 52. So, I have to increase this by next value, that is what? 32. So, that for 52, by adding which number we are going to get? By adding 32 and 16, it becomes 48. 48 plus 4, 52. Okay. So, the remaining value will be 0. So, as I discussed, for addition or subtraction, whatever it could be, the number of minuend and subtrahend value, the number of digit must be same always. Okay. So, if it is having 6 digit, that is in the terms of what? Zeros and ones. So, in the minuend or subtrahend also should be same number of digits. So, that I have to take 0 here. Without that, you are going to miss the problem. So that you have to understand one thing, whatever could be the value, so you have to match it with another one. So if you have 5 digits in the minuend, then there must be 5 digits exactly in the subtrahend. Okay. So now we got to know this is minuend and this is subtrahend. So what I am going to do in the second step, we have to find the ones complement of a subtrahend. Okay. So in the first step, we have to find the ones complement of a subtrahend. The subtrahend value is this one. I am going to complement it. We'll see what we are going to get. So this become 001011. Okay. So this is subtrahend value, that is ones complemented subtrahend value. Now I have to add this subtrahend value with a minuend. So what is the minuend? That is 011001. So you can see here 011001, and ones complementation of the subtrahend is this number, that is what? 001011. So we'll see the addition now. 1 plus 1, 0, carry 1, 1 plus 0, 1, 1 plus 1, 0, carry 1, 1 plus 0, 1, 1 plus 0, 1, 1 plus 1, 0, carry 1, 1 plus 1, 0, carry 1, 0 plus 0, 0, 1 plus 0, 1, 1 plus 0, 1. Okay. Did we got any carry here? No. So if there is no carry, then this will be second type. Okay. After that, I have to consider there is no carry. Then I have to take a ones complement of a given number. Then I have to attach minus sign to the given answer. So I got this answer. What was the answer? 100, 100. I have to recomplement it. So that too by making use of ones complement. So it becomes 0, 1, 1, 0, 1, 1. So that I have to put negative sign for the answer. So now what we got, that is minus 0, 1, 1, 0, 1, 1, which is the base 2. So if you consider this for the 8, 4, 2, 1 format, what we are going to get? So that is 16 plus 8, 24. 24 plus 2, 26. 26 plus 1, 27. That is what? 25 minus 52 is what? 27. Which 27 it is? Which is highest value? That is 52. What is the signature of 52? That is mine. So that we have to put sign over the answer. Okay. This is how we have to solve the given binary number subtraction by making use of ones complement. So we'll see the twos complement problem now. That is what? Subtraction using twos complement. So here also there will be two cases. Okay, as I discussed for the ones complement, here also we have two cases. That is what? When the minuend is greater than subtrahend, or when the subtrahend is greater than minuend. So we'll see the case 1 now. That is what? Subtracting a smaller number from the larger number. So here we have to take we are performing subtraction of a smaller number from the larger number. That is what? When the minuend is greater than the subtrahend. Okay. Find the twos complement of the subtrahend. So instead of taking ones complement, we have to take twos complement because we are dealing with twos complement subtraction. So that I have to find the twos complement of a subtrahend. How I am supposed to find this twos complement? I have to take the ones complement first. Then I have to add 1 to the LSB. So that will going to give us twos complement. So that find twos complement of a subtrahend, that will be step 1. In step 2, add this to the minuend, same as the previous one. Okay. In step 3, carry is generated. So we are going to get a carry. When we are going to get a carry? When minuend is greater than the subtrahend. Okay. So we have to discard that carry. We have to discard. So in the ones complement, we are going to add that carry to the LSB. But in the twos complement, we have to discard. So why? Because once it is complemented, it will going to give the negative sign. Again, if I add 1, that will going to give the positive value. So that is what we are doing in the twos complement. So that no need to take that carry again to the LSB. So that carry will going to be generated, we have to discard it, then the remaining bits will going to give the difference. That is what we are going to get as a result. We'll see the problem now. Subtract 9 from 17 using twos complement. Subtract 9 from 17. What we have after from? That is what? 17. That will be minuend value and this will be subtrahend value. So let me write minuend is 17 and subtrahend is 9. Okay. Then what is the equivalent value of this 17? That is what? 10001. That is what? I am going to take 16 and 1. So in order to add 16 and 1, we are going to get 17. Next, subtrahend is what? 9. How we are going to get 9? By adding 8 and 1, we are going to get 9. So that 0, 1, 0, 0, 1. Okay. This will be my subtrahend value. I have to find twos complement of a subtrahend. Right. So we'll do that now. First is what? 0, 1, 0, 0, 1. This is the value of my subtrahend. I have to find twos complement. How we are going to find twos complement? That is what is equal to ones complement plus 1. Right. This will going to give us twos complement. So now we have a subtrahend. I have to find the ones complement. So now what it will going to lead me? That is what? 1, 0, 1, 1, 0. This is ones complement. I have to add 1 to the LSB, 0, 1, 1 and remaining value will be as it is. This is what the value of my 2's complemented subtrahend. I have to add this 2's complemented subtrahend with the minuend value. That is what the value of 17 here. Okay, this is what I have did. 1's complement of a subtrahend, that is what 9 is 10110. That is what we got here. I have to add 1 here, then I am going to get 10111. Okay, so in the next step what we are going to do, then we have to add this 2's complemented subtrahend with the minuend, that is what greater value. So minuend is what 17, that the value is 10001. Okay, then 2's complement of a subtrahend, what we are going to get, that is what 10, this value 10111. So now we have to perform the addition. We'll see the addition now. 1 plus 1 0, carry 1, 1 plus 0 1, 1 plus 1 0, carry 1, 1 plus 0 1, 1 plus 1 0, carry 1, 1 plus 0 1 and 1 plus 0 1, no carry, then 1 plus 1 0, carry 1. So we are going to get a carry, but what is there in the 2's complement condition? If we get a carry, we have to discard it. So when we discard it, no need to add this to the resultant or no need to add this to the final value. So I have to discard that carry, then that was step 3. At last I have to write the difference. So by discarding this value, I am going to get only 0 1 0 0 0. So I can neglect the 0 also because that is at the left side. Okay, so ultimately we are going to get 1 0 0 0. So that what it means, 17 minus 9 is what? How much then? 8. So 9 is equivalent to 1 0 0 0, which is of base 2. This is base 10 because decimal, this is base 2 because binary. Okay, this is how we are going to find the binary subtraction, that too by making use of 2's complement. So now we'll see the case 2, that is what when we are working with when the minuend is lesser than the subtrahend. So here subtraction using 2's complement, that is case 2. We are trying to subtract a large number from the smaller number. That is what? When the minuend will going to be lesser than the subtrahend. So the number which is at the top will going to be less than this lowest number or a lower digit. That will be the scenario. Then what is the step 1? Find the 2's complement of a subtrahend. Here also we have to find the complement. Which complement? That is what? 2's complement. We have to find the 2's complement. Then in step 2, add this to the minuend. I have to add this 2's complemented value with the minuend. That will be my step 2. So in step 3, there will be no carry. Here we won't get carry. So in the case 1, we will get carry, but I have discarded. But in the case 2, we won't get any carry. So that there will be no carry. Hence, take the 2's complement of the answer. We have to take 2's complement here. But in the case 1, we will going to get a carry. Then I have to discard and I have to write the answer as it is. But here, we won't get any carry. But we have to take a 2's complement of a given answer. That is what we got as an answer. That has to be 2's complemented. And we have to place a negative sign in front of that. Okay, so you just understand the concept and work out the problems. Okay, don't think it as a complicated one. So it will be easier. You just have to work out. Okay, we'll see the problem so that you can understand. Subtract 47 from 26 using 2's complement. So here we are subtracting a number called 47 from 26. So after from we have 26, so that it will be my minuend and this will be my subtrahend, right? So what is the condition here? What is the scenario are we dealing with when subtrahend is greater than a minuend or else minuend is lesser than the subtrahend? Okay, that is what the case here, but we have to subtract 47 from 26 by making use of 2's complement. We'll see which is minuend, which is subtrahend now. So minuend is what? 26, and the equivalent value of this 26 in the binary is 0 1 1 0 1 0. So let me put 8 4 2 1 and here 16. 16 plus 8, 24, 24 plus 2, 26. Okay, so for subtrahend, that is what, 47, but the 16, 8, 4, 2, 1 is not enough for me to get 47, so I have to increase it by 32. So now it becomes 32, so that by adding 32 and 8 and 4 plus 2 plus 1, I am able to get 47. This will be my subtrahend. First we have to write which is minuend and which is subtrahend, and you have to find the binary equivalent of minuend as well as the subtrahend. That is step 1. After that, in a step 1 itself, I have to find a 2's complement of a subtrahend. So which is the value of subtrahend? That is 1, 0, 1, 1, 1, 1. This is the value of my subtrahend. I have to find a 2's complement of 8. How we are going to find? First, we have to find 1's complement. Later, I have to add 1, right? So that 0, 1, 0, 0, 0, 0, 1. 0 plus 1, 1, and the remaining will going to be same. That is what I got here, 0, 1, 0, 0, 0, 1. Okay, this is step 1. I got a 2's complement of a subtrahend. Then I have to add this 2's complement of a subtrahend with the minuend. That is what the step 2. So then which is the minuend here? That is what, this value. So we have to add this 2's complemented subtrahend with this minuend. That is what here, minuend and addition with 2's complementation of the subtrahend. So that 0, 1, 1, this value 0, 1, 1, 0, 1, 0, and the 2's complemented subtrahend is 0, 1, 0, 0, 0, 1. So now we have to perform the addition. So we'll see 0 plus 1, 1, 1 plus 0, 1, 0 plus 0, 0, 1 plus 0, 1, 1 plus 1, 0, carry 1, 1 plus 0, 1, 1 plus 0, 1. Do we get any carry here? No. So that is what in the step 2. We won't get any carry, but we have to recomplement it. That is what, we have to do the 2's complement and we have to put negative signature. Okay, so we'll do that now. I have a value called 101011. This is my answer, but I have to complement it. I have to find the 2's complement. First, I have to find 1's complement, then I have to add 1 to this number. So here, we are going to find a 1's complement of a answer. So that is what we got it as answer, that is 0, 1, 0, 1, 0, 0, and after the adding the value of 1, I am going to get 2's complement. Okay, so 0, 1, 0, 1, 0, 0 plus 1. So 0 plus 1, 1, 0, 1, 0 and 1, 0 will be as it is. I have to put the negative signature here. Okay, that is what it will become, minus 21. Okay, so that here 26 minus 47, that will going to gives us minus 21. Okay, this is how we are going to do the subtraction of a binary number, that too by making use of 2's complement, which is related to case 2, when the minuend value is lesser than the subtrahend value. Okay, so understand one thing, we are going to do the binary subtraction using 1's complement and 2's complement. In both the complement, we have two cases. Okay, when the minuend is greater than subtrahend or when the minuend is lesser than subtrahend. So this is important for 5-mark question. They can be asked for either 1's complement or 2's complement. I hope you all understood with my today's class. In my next session, we are going to learn with the computer codes. So, let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.